Now, we define spatial intelligence as AI's ability to build a 3D model of the world, understanding depth, geometry, how objects relate to one another. And with this, AI can reason about space the way that humans do, which means predicting how things move, what might happen next, how to act safely and effectively in the real world. Let me give you an example. If I'm given a picture of a scene, I think I need to be able to imagine what would happen if I was going to move from the original position. This is what we mean by making a mental picture of the space around us. I need to be able to imagine myself walking around objects, moving up and down. What happens if I tilt my head, or I go and I turn off a light, and so on and so forth. This is what we call novel view synthesis. It means being able to effectively take the original camera and moving it around so that you can literally take a walk in the scene. For consumer, it means better self-driving cars, so being safer when you're in a self-driving car because the car can understand the space around it, can maybe imagine what's around the corner. Cheaper goods, right, produced by autonomous factories manned by autonomous robots, or very smart AI assistant as you're going to wear a pair of AR glasses in the future, right? For industries, it means precision healthcare. Imagine a surgical robot. Efficient logistics, having this robot find their way around in a huge warehouse, right? And I think with all of that, it means that the cost of producing goods is going to drop over time. And the hope, at least, is that the promise of AI is that it's going to leave us in a state of abundance where there's going to be enough food and enough goods for most human beings on the planet, and that we're going to be able to focus on other more dignified tasks than having to find food or and make two ends meet. So why now? Why spatial intelligence is relevant now? Well, AI has reached incredible heights in language and vision, but it's starting to hit a wall, right? It scrapped about every text token it could on the internet, every possible image and video it could on social media. And I think in order to get to the next wave of progress, which is the ability of AI to understand the physical world, it needs similarly what I would call planetary scale data set of 3D data, right, in order to be trained. And the main problem is that that data doesn't exist. That's the core bottleneck that needs to be solved now, right? Because until we solve it, we're going to stall, right? So all of the promises of superior autonomous driving and surgical robots and AR assistant and abundance and cheap goods and so on, it's not going to happen until we pass that bottleneck. So people have tried to use different type of technique to cheat, right? In a sense, you can use 2D videos, right? If I take a camera and I move about the world, I actually get a pretty good sense of the 3D structure, the spatial structure of the world. The main issue with 2D videos, is that they mix the temporal component, right? The natural movement of the world around you with what I call the parallax motion, right? Imagine if you were freezing the world and then just moving the camera around, right? So in a 2D video, these two axes are actually conflated, right? They're just merged. So that creates issues. You can try to use synthetic 3D dataset, right? It's an approach taken by NVIDIA. For example, their Cosmos model, right? So you can do very accurate 3D rendering of different types of environments, even with nice lights and shadings and so on. And you can actually try to train spatial intelligence in this context, and it's working to a large extent. But what is missing is what I would call the long tail of real-world scenario, messy environments, when you have complex lights and partial occlusions and semi-transparent materials, all kind of reflections and so on. And I think in order to get a spatial intelligence that works in these cases, which are actually, fundamentally important, because very often is in this type of environment, a foggy road and so on, with kind of your light beam reflecting, partially off the droplets of fog, right? These are in this typical environment that you want a spatially intelligent being to perform, and this is where we don't have data, right? So in order to really get performance in this spatial intelligence, we're going to need to gather a data set of real-world 3D data that is able to cover this long tail of scenarios. So we just discussed how spatial intelligence was requiring a long tail of real-world 3D data in order to be trained, all the complex lighting environment and some occlusions and other possible messy situation that can arise in the real world that doesn't really arise with synthetic data. So this is really what's holding the field back, right? Today is that how do we solve for the collection of this real-world data corpus? What you need to collect 3D data is what we call the stereo camera, right? You need two eyes being able to record the world as you evolve through it. There's different technologies to do, but that's a simplification, right? And if you think of entities that have these two cameras, these two eyes today, I think first come to mind maybe you have AR glasses, right? So Meta is very adamant that very quickly AR glasses are going to be adopted. They have stereo cameras, and as people wear them and move around the world, and they naturally record the environment. I think it's true, but I think we're probably at least 10 years out from having a meaningful amount of people evolving in diverse enough set of environment wearing these glasses. Right? Well, similarly, you could have robots, right? So you can have autonomous robots, again having two cameras for their eyes, evolving in different places. I think it's going to be true in warehouses. Maybe you're going to start to see some domestic robots, maybe vacuum cleaner or something to help in your kitchen, right? So they're going to be able to collect data, I think, in these very particular and narrow use cases. Same for cars, right? Every car today has a kind of driving assistance system that has multiple cameras that can record roads, right? And this is great to capture environment on roads. So we need to ask ourselves, what is a good collection device that is diverse enough and spread out enough, not to the tens of thousands or the hundreds of thousands, but you'd want ideally billions of devices that have the ability to collect that data, right? And if you think about it, the answer is obvious. That device is the smartphone. Right, so how do we collect this planetary scale corpus of 3D data? It has to be through the smartphone. Smartphone is the only device that every person on the planet owns today. You have billions of them in circulation. They're familiar. You take them with you everywhere you go. And I think people are already accustomed to taking and perhaps more importantly, sharing pictures through social media, which is how you get access to that data and are able to actually train AI, right? That's actually important. Today, phones already have the capability to capture the required spatial data, right? They have all kinds of sensors and multiple camera available. There's just no reason for people to actually record the 3D picture. Like they wouldn't even know what to do with it. Immersity changes that fundamentally, right? By upgrading every phone with immersive displays and AI that is going to guide you in the capture and making sure you always get the perfect shot. We give people reason to capture their world in 3D and to share it, right? It's fun. You can preview the capture in an immersive way. You can relive it immediately. You can sort through the bad picture, the good pictures, and you can text them and you can post them directly from your device, the same way that you post to Instagram and TikTok today. So we're not asking you to change any of your habit. So this creates a virtuous circle, right? A flywheel where people capture because they love the experience. Platforms such as Instagram and TikTok and YouTube will support it because users demand it. And the global 3D data set that is needed to train spatial intelligence, it just grows naturally as a byproduct, right? Not in a forced way. So this natural flywheel will accelerate the path to spatial intelligence and benefits consumer, all the industry partner, the OEMs, the telcos, the big tech as a whole, right? So this is the only natural and organic way in which that vast data set can be adopted just by mimicking what has been done with 2D videos and pictures to date. Well, every major shift in technology has been powered by a catalyst. The internet gave us the text that fueled language models. Social media gave us the images and videos that fueled vision AI. So Leia's role, the role that we see for the company, is to unlock the catalyst for spatial intelligence, which is making spatial capture natural, valuable for people, and woven into everyday life. But I think we think of this evolution as perhaps a broader trajectory, right? I think the ongoing progression that brings our media ever closer to the real world and to each other as humans, right? So if you think of the evolution of media from silent film, then we added sound, and then we added color, and then we added the ability to touch and interact with it. And then, finally, with the last mile from flat images to immersive experiences, every leap in media has amplified human connection and expression and how we relate to the real world, right? So spatial intelligence with that lens is this next great shift, right? And don't get me wrong, it's not about replacing human experience, by robot or machines, right? It's about grounding AI into our world so it can help us live safer, smarter, and more abundant lives. That's the future we're building towards, technologies that sees the world with us and for us, so humanity can flourish.